Hi, this is Maggie. In this video, we're going to talk about exceptions, which are a mechanism in Java for handling exceptional conditions within a program, such as an I/O problem, an attempt to access an array beyond its bounds, or an attempt to treat a null pointer as if it were an object. We'll begin with what happens when we add a throws clause to a method header. This is the Proverb game.java example from our video on building a set of collaborating classes in Java. I'll link the video here if you're interested, but it isn't necessary to watch that video to understand this one. All you need to know is that the ProverbManager class has a readProverbs method called by the constructor that instantiates a scanner by passing in a file object. Now, I'm passing in a file that I created and that I know exists, and I'm checking if the file exists before instantiating the scanner in the readProverbs method. So I'm going to comment out the code that checks if the file exists, and I'm going to pass in the name non-existent.txt, which is not the name of a file in this project, so that we can see the stack trace that results when the file not found exception is thrown. So when I run the program, we get the error message and the stack trace. The error message says non-existent.txt, the system cannot find the file specified. The stack trace shows us the series of method calls that led to the method that threw the exception back here in file input stream.open0. We can see the line in each file on which the calls are made. And in Eclipse, we can click to go directly to any of those methods. Every method that invokes file input stream.open0, or any method that calls that method, or any method that calls a method that calls that method, must add a throws clause to the signature of the method, or one of them must catch the exception. Here, every method has a throws clause. When an exception is thrown, Java goes through the stack, the methods that were called that led to the method throwing the exception, until it finds a handler for the exception. If all of the methods throw the exception, then the Java virtual machine handles the exception in the way we see here, by printing the message and the stack trace. This is an image of the Java inheritance hierarchy for Throwable from Oracle's website. There is a superclass Throwable that has subclasses error and exception. Errors are serious problems that we are not concerned with in ordinary programs. Exceptions come in two basic varieties, checked and unchecked. In this image, you can see the subclass runtime exception, which is an unchecked exception. Examples of runtime exceptions include null pointer exception, index out of bounds exception, and arithmetic exception. When we are required to add a throws clause to a method header, it is because that method throws, or invokes another method that throws, a checked exception. The checked in checked exception means the compiler is checking to see if the exception is either handled or explicitly thrown. If it isn't, the program won't compile. The compiler does not force us to acknowledge unchecked exceptions in this way, because unchecked exceptions are less predictable and are often caused by programming errors. You can throw and catch or handle both checked and unchecked exceptions, but you are only required to handle checked exceptions. We have seen how to pass them up the runtime stack with a throws clause in the method signature. We should also document in the Javadoc that a method throws an exception. Let's add that to our readProverbs, constructor, and main method Javadoc comments, throws file not found exception, thrown if the Proverbs file cannot be found in the default directory. It is important to document exceptions that are thrown in a method so any part of the program that calls the method knows to throw or handle the exception. It is part of the method's interface, its contract with methods that use it. Now, we already had code that checked if the file exists before trying to read from it. If the file isn't found, the ProverbManager had code to create an empty array list of proverb objects. This isn't ideal because it doesn't let the calling method know there was a problem. The calling method passed in a file name, so to complete execution as if that file was read when it wasn't can lead to errors. Let's redesign this to give control over how to respond to the calling method, the one that passed the file name in. Maybe A file not found is a serious problem, and we don't want to continue under those circumstances. Or maybe there's a contingency file, and the calling method might want to try again with a different file. Maybe the calling method is getting the file name from the user, and they need to let the user try again in case it was a typo. If the Proverb Manager handles the problem, then the Proverb game never gets a chance. So let's let that file not found exception be thrown, and let's let the Proverb game catch it and handle it in its own way. First, we'll remove the throws clause from the method signature. The main method will no longer throw an exception. That means we have to handle it. To do that, we wrap the code that could throw the exception in a try block. That code is the constructor for the Proverb Manager. So we'll write, before that constructor, the keyword try, and then open curly brace, and after the constructor, we'll put a close curly brace. After the try block, we put a catch block. The catch block is the keyword catch, and then in parentheses, the type of exception we're catching, and a name for the exception object. It's standard to call it E, but you don't have to. We're catching an exception of type file not found, so we'll write file not found E, close parentheses, open and close curly braces. That defines our catch block. Now I should move my variable declaration code for the Proverb Manager outside of the try block, so let me do that. And Eclipse is warning me that the Proverb Manager object may not have been created in the lines that follow our try catch block. That is because in the try block, if the file not found exception is thrown, the constructor does not finish executing. Control will flow to this catch block as soon as the exception is thrown. So we need to figure out how to deal with this in the catch block. We have some options depending on whether the design is still fluid, and we can modify the Proverb Manager class. If we can't modify the Proverb Manager class, we have the option of including the entire program in the try block, so that we'll try to create the Proverb Manager object from the file, and if successful, we'll continue, and otherwise we'll catch the exception. I'll show you what that looks like. We move all the code into the try. But unless we're going to do something very different from the JVM in that exception, it's basically the same effect. The program crashes with an exception. Let's mimic the JVM exception to get a little practice with that exception object. The JVM prints the message and the stack trace. We are given, in the catch clause, a parameter which is an object with information about the error. We called that object E. We can send messages to the object. So let's print e.getMessage. And we can send the print stack trace message to E. When I run that, notice that we see the message, and then the print stack trace method prints both the message and the stack trace. Now, you may not want or need to interact with the exception object, but you can send those messages and get that information. If you're logging the error but continuing with execution, you might want to log that information. If our exception handling is going to be the same as the JVM exception handling, we should just throw the exception. So let's try something different. Okay, so what's another option? We can't proceed without a Proverb Manager. In our case, we're passing in a hard-coded file name, a literal string. Where does the file come from? Maybe we could construct or download a new file if the file has been deleted or moved. Maybe we tell the user there's been a fatal error and they need to reinstall the system. We could display a custom message, system out print line, the Proverbs file non-existent.txt has been moved or is missing. Please restore the file or reinstall the program. The stack trace would not be useful to the user, but this message will hopefully make sense. Let's try something else. I'm going to put the program code back below the try block, all except for the code that throws the exception, the constructor. Suppose we're going to redesign the system to handle this, and we create a default constructor for Proverb Manager that takes no parameters and doesn't read from a file. This constructor will hard code in the Proverb objects. So just copy the old constructor, but create a new array list and then add some proverbs to it. I'm going to pass in empty strings to save time here, but we can imagine these are constants in the program for the proverb pieces that we'll pass in. Now in the catch clause, we can invoke the no-arg constructor and proceed with the game. What's the best option? Probably failing and informing the user they need to reinstall the game, or put the file back if they moved or deleted it. But the best option will depend on the system you're designing, so it's important to understand what's possible. If you're going to crash and print the stack trace because the program can't recover from the error, and you need to do a little more debugging work to fix it, as with most unchecked exceptions, then just let the JVM handle the error. If you're going to crash, but there's something meaningful you can do, like tell the user to find that file or reinstall, then handle it and take your meaningful approach. If you're not going to crash, but you'll need to take steps before you can proceed, then take the steps in the exception handler and proceed with the program. To practice with this and to learn more, I highly recommend the open source, in other words, free, textbook, Java Object-Oriented Problem Solving. Read the exceptions chapter and practice with the exercises there. I'll include a link to the book in the description. I'll also include links to some exercises that you can try to add exception handling to the Proverbs game. The code will also be available in my GitHub repository. Have fun with it.